Hi, I'm Olga Mali and this is Math Talk. My guest is Ty Lewis, student of our college. Hi, Ty.
Hi.
Good to have you again here in our studio. Today we are going to show our students how to work with factorials, permutations, and combinations. And mainly we will show how to do all the work manually without calculators. So we will start with factorials. So Ty, I guess you're familiar with factorials. So what is the formula and notation for factorial?
So the formula for a factorial is n factorial. The exclamation point signifies factorial, which is n times n minus 1 times n minus 2 all the way down to 1.
Okay, great. So, and we use this formula and this factorial formula to find number of different ways to arrange n distinct objects. Now, what about number of permutations? So I will write formula here. Number of permutations can be calculated according to this formula, n factorial divided by n minus r factorial. And using this formula, we can find number of arrangements of n items taken r at a time. So we have total n items. Out of n items, we taken r items at a time. And another formula is formula for combinations, which looks like this. N, R, and we have n factorial over r factorial and minus r factorial. And with this formula, we can find number of subsets of n items taken r at a time. So now let's have a look at properties of factorials, permutations, combinations, how to perform calculations. So what if we need to find 3 factorial? So what do we need to do?
So 3 factorial is you just multiply this number by all the numbers that are below it, going all the way to 1. So it would be 3 times 2 times 1 equals 6. The 1 doesn't really make a difference, but we include it there as a convention.
Yes, we need to just include it to show we know how to use the formula. Okay, what about 5 factorial? How do we do this?
Okay, so this is the same thing, except we start at 5 instead of starting at 3. So it's 5 times 4 times 3 times 2 times 1. This is 6. So this, if you multiply by 5, would be 30, and then that's going to be 120.
Okay, now, tricky question. What if I have 0 factorial? Do you know what is that?
So, there's a rule, and that's 0 factorial is 1. So, there's one way to arrange 0 objects. So, the factorial is just the number of ways to arrange this many number of objects. But since there's 0 objects, there's only one way to arrange it, which is basically nothing.
So we have nothing, so we have nothing to arrange, so it's just one option. Yet, we need to remember that 0 factorial equal to 1 is a special definition. Okay, yes. Great. Now let's have a look at this. What if we have 6 minus 4 factorial? How do we deal with this?
So 6 minus 4, by basic arithmetic, 6 minus 4 is 2. So since it's in the parentheses, you do that first. So 2 factorial equals 2.
So basically we are using rules of operations, right?
Yeah, order of
parentheses first, yeah, order of operations. Okay, what about this? If I have 6 factorial over 3 factorial, will it be 2 factorial?
No, because...
Okay, so not 2 factorial. So what do we need to do?
So we'd have to expand this out. 6 times 5 times 4 times 3 times 2 times 1. And this 3 factorial is just 3 times 2 times 1. Now if you look closer, this right here, this is 3 factorial.
Yeah, so this is just 3 factorial, and the same what we have in the denominator,
Yes.
right? 3 factorial. So what you are saying, we don't have to write even 3, 2, 1, 3, 2, 1. We don't have to expand. So what we can do here, we can see that we don't have to expand 3 factorial. We can just write 3 factorial here, 3 factorial here, and just reduce it. So what we are getting here, we're getting 6 times 5 times 4 equal to 120. So if we want to find 100 factorial divided by 100 minus 2 factorial, do we have to write all these 100 numbers in the numerator? Tai, how to do that quickly?
No. So, like we did in this problem, we just have to use the parentheses first. So this is going to be 98.
98 factorials. In numerator, we have
99 times 98 factorial.
Okay, and now what you are saying, we can just cancel out these 98 factorials, and the answer will be just 100 times 99, that is 9900. Okay, great. So again, we don't have to write every time all these numbers. We don't need to write here 100 times 99 times 98 times 97 and so on and so on. We can just write 98 factorials and keep 98 factorials in the denominator. Okay, Tai, I think you are ready to have a look at some specific problems related to permutations, combinations, and factorials. So what about this problem? In how many ways can you line up 6 different books on a shelf? What are we using? Factorials, permutations, or combinations?
So we're going to be using factorials because we're just arranging books on a shelf. So it would be 6 factorial, which equals 6 times 5 times 4 times 3 times 2 times 1, which equals 720. Way to calculate this is you don't have to multiply them all at once, but like you can say this is 30. Then
so we can say this is 30. What else?
Times 4 is going to be 120, 360, 720, and the 1 will make no difference.
Okay, great. So this is just how to arrange 6 different books on a shelf. How many 3-digit numbers can be written using digits 3, 4, 5, 6, 7, and 8, and digits are not repeated? So what are we going to use, permutations or combinations? I mean, order is important or not?
So order is important because the number 7, 6, 4 and the number 4, 7, 6 are not the same number.
Yeah, they are not the same number. If we talk dollars, I would love this one better.
Yes.
Okay, so that means we're using permutations, right? So we have 1, 2, 3, 4, 5, 6 numbers. So we need to use permutation 6, and we're choosing 3. Okay, so what will be our expression?
So here our expression would be 6 factorial in the numerator over 6 minus 3 factorial. And so this would be 6 factorial over 3 factorial, which equals 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. This right here is 3 factorial. This right here is 3 factorial.
So we didn't have to expand 3 factorial 3 times 2 times 1. We cancel them anyway.
Yes.
So everything is cancelled here. And our answer is 6 times 5 times 4, which is 120. Great. Let's have a look at this problem. How many ways can a group of 10 students select 4 representatives to the student council? Okay, the same question. Is it permutation problem or combination problem?
It's a combination problem.
So these 4 representatives,
they can be in any order. So like
they can be in any order. They will be still the same 4 representatives, right? So that means we are using number of combinations. So out of 10, students, we're choosing 4 students, order is not important. So what will be the expression?
So the expression would be 10 factorial over 4 factorial times 10 minus 4 factorial.
Okay, great. So now I see we have 10 factorial, this is 4 factorial and 6 factorial. So how to deal with this problem? Do we need to expand 10 all the way to 1 or not? We can stop somewhere.
We don't. We only have to expand it to 6. So
Yeah.
10 times 9 times 8 times 7 times 6 factorial over 4 times 3 times 2 times 1 times 6 factorial. That's going to cancel.
Okay, great. Can we cancel something else here?
Yes, so 4 times 2 is 8. So if we cancel 8, those are going to cancel.
Okay.
This can become a 3. That's going to cancel.
So we divide 9 by 3.
Yeah, but
Okay.
1 doesn't matter, so let's just get rid of it. So
Okay.
this is going to be
so
10.
What do we have? Just 10 times 3 times 7, which is very easy to calculate.
70 times 3, 210.
210. I just want to mention something here. Even though we remove the 1 in the denominator, we understand that it's still there. Any integer can be written as a fraction with denominator 1. Okay, great. So I hope that helps. We told you about factorials, permutations, and combinations and how to do all the work manually. Thank you for listening and watching. Thank you, Tai. That was Math Talk with Olga Mali.